So now let us look at some standard loci related to circles. So first, mod of z minus z1 whole square plus mod of z minus z2 whole square is a constant. The squares of the sum of squares of distances from two given points is a constant. So if you have 2 points z1 and z2, z is moving such that the square of this distance plus the square of this distance is constant. So that this locus will give you a circle. So if you have no squares, then the locus will be an ellipse. If you have squares, the locus will be a circle. You can very easily derive this by taking x as x, z as x, y, z1 as x1, y1 and z2 as x2, y2. Next, if you have a special case of this, mod of z minus z1 whole square plus mod of z minus z2 whole square is exactly equal to mod of z minus z1 minus z2 whole square. What is the meaning of this? So you have z1, you have z2. So z is such that the square of this distance plus the square of this distance is exactly equal to the square of this distance. A square plus b square is equal to c square. This implies this angle is 90 degrees. So z is moving such that this angle is always equal to 90 degrees. It means z is moving on a circle whose diameter is z1, z2. So this represents a specific circle with z1 and z2 as endpoints of diameter. Endpoints of diameter. So this is a circle with z1 and z2 as endpoints of diameter. The same condition can be expressed in terms of argument like this. So what is the meaning of this locus? Argument of z minus z1 by z minus z2 is equal to plus or minus pi by 2. That is, if you have two complex numbers z1 and z2, my complex number z is such that the angle between the vectors z minus z2 and z minus z1 is either plus or minus pi by 2. So what is the vector z minus z2? That is the vector joining z2 to z. That is this vector. This is the initial vector, right? The vector in the denominator is the initial vector. What is z minus z1? This is this vector. This is the final vector. So the difference between the argument or the angle between these two vectors should be equal to either plus pi by 2 or minus pi by 2. That is pi by 2 in either clockwise or anti-clockwise. It means z is such that this angle is maintained as 90. So is this exactly same as this condition? So here you are given a condition regarding the lengths of the sides of the triangle. Here you are given information regarding the angle between the vectors. So here also, if z has to maintain an angle of 90 here, it has to move on a circle with z1 and z2 as diameter. So again, this also represents the same locus. So the next standard locus is argument of z minus z1 by z minus z2 is equal to 0 or pi. So if this is equal to plus or minus pi by 2, we have seen that the locus is a circle with z1, z2 as diameter. Now instead of plus or minus pi by 2, if you have 0 or pi, what will be the locus? What will be the nature of locus? So what is the meaning of this? You have a complex number z1, you have a complex number z2. So now z minus z2 is the vector joining z2 and z. So if you have a z here, so this complex number represents this vector, and the numerator, which is the final vector, this is the initial vector. The final vector is z minus z1, that is this vector. So the angle between the initial and final vector has to be equal to either 0 or pi. That means these two should be in the same direction or in the opposite direction. Obviously that means you cannot form a triangle here because this angle is 180. So where should this point come? So this point has to fall on the line z1, z2. This point has to fall on the line z1, z2. If it falls on the line, this angle will become equal to 180 degrees. If it falls outside the line segment Z1, Z2, the angle will be equal to 0 degrees. Because if you have Z here, the vector joining Z1 and Z is in this direction. The vector joining Z2 and Z is also in this direction. What is the angle between them? 0 degrees. So corresponding to 180 degrees, you get line segment Z1, Z2. Corresponding to 0, you get the portion of the line Z1, Z2 outside the line segment Z1, Z2. So I hope this is clear. If this angle is plus or minus pi by 2, then the locus is a circle. If this angle is 0 or pi, the locus is a straight line joining Z1 and Z2. So now, argument of Z minus Z1 by Z minus Z2 is some angle theta, which is not equal to 0 and pi. So other than 0 and pi. So any angle other than 0 and pi, you won't get a straight line. So what does this represent? So if you have a complex number Z1 and Z2, what this statement says is, if you have a complex number Z, the vector joining Z2 to Z and the vector joining Z1 to Z will always make a specific angle theta between them. This angle is not changing. If this angle does not change, this angle also does not change. That means my Z is moving such that this angle is constant. So can you guess the locus? Yes. The locus is a sector of a triangle, of a circle. So you won't get the complete circle, sector of a circle. Because you don't have both plus or minus theta. So you cannot go on both sides of Z1, Z2. Because if on one direction, if you go from initial vector to final vector, if the angle is counterclockwise, on the other direction, the angle will be clockwise. So this represents something like a sector of a circle. If it is exactly plus pi by 2, it will represent a semicircle. If it is equal to minus pi by 2, it represents the other part of the semicircle. If it is equal to plus or minus pi by 2, it represents both parts, hence the complete circle. If the angle is any number other than plus or minus pi by 2, you won't get a complete circle. You get some sort of sector of a circle. Thank you.